So what we have not done for the most part so far is kind of explain why sometimes things are the way they are. Okay, I try to, as much as I can with the amount of math that we understand and we know, but I think as we work through this chapter, we're going to have a lot more situations where I can actually give you kind of a logical understanding of why you are allowed to do some things and why you're not allowed. So what's the number one thing in mathematics they tell you you're not allowed to do?
For like what?
Division. Divide by zero. Not allowed to do it, right? Do you know why? Because it says undefined, doesn't give me anything. They've told, maybe my teachers have told me I'm not allowed. You're not allowed to do it. And it's a golden rule, not allowed to do it. But why? Like, when you ask for something at home and your parents say no, and you ask why, and you say, because I say, is that a legit reason for you as a person? No, but it's the law, right? Golden rule, because mom and dad said so it's not happening. Okay? Mathematics should never be that way. Mathematics should never really be, this is it because it is, okay? Because I said so, because, there's no question. There's a few things that we have to have that way. They're called postulates or axioms. But for the most part, everything has a why to it, okay? And eventually, my hope for you as you progress through this course and your next couple courses is to not just be able to do the work, but to know what is allowing you to do that work and why you're going through certain steps that you're going through. So my hope is that eventually in this chapter we can see some of those things, okay? In getting to that point, though, today we're going to just make the assumption that what I'm giving you are facts, because we don't know enough algebraically yet with exponents to actually prove why the stuff that they're talking about right now today is what it is. It won't be until section 7.3 that we can really discuss why something raised to the 0 power, for instance, is equal to 1. Okay, but that's what we're going to talk about today is powers or exponents that are 0 or negative. Okay, 0 or negative. So the first one says 0 as an exponent. What this says, for every non-zero number a, so any number that you choose, as long as it is not 0, if you raise it to the 0 power, it should equate to 1. So what that means is, if I take 3 and raise it to the 0 power, it should give me 1 back. If I take 13 and raise it to the 0 power, it should give me 1 back. If I take pi and raise it to the 0 power, it should give me 1 back. Does that make sense? Okay. Because it can be any number, let's say I just call it m. M raised to the 0 power will give you 1 back. Okay. Anything that is non-zero raised to the 0 power is going to give me 1 back. Okay. Something that might be important for us to write down as well, just because I'm going to use this terminology as we progress. Like this, if I just say like a to some number n, okay, the a, that number, a lot of times, because this is an exponential expression right now, we call that the base, and obviously then n is the exponent. Okay, so the base is always the number or object directly in front of the exponent, right? Does that make sense? Okay, and that's what we've learned with parentheses, exponents, multiply, divide, add, subtract, right? If I've got an exponent, it goes directly to the thing that it is behind, right? Or the thing that is directly in front of the exponent. And we call that thing in front of the exponent a base. Okay, so that's critical here. So in this case, 3 would have been the base, 13 is the base, pi is the base, m is the base. But every one of those things raised to the 0 power is 1. Okay? Now, there are some discrepancies with like 0 to the 0. And what does that equal? Okay? I'm going to explain to you guys, and this is just staying aligned with what our text says, okay, and what the Common Core says. That is an undefined value, and I'm in agreement with that. Undefined Okay? And it makes sense because the rule, which is what we call a theorem, the theorem up there says for every non-zero number. Well, if I choose 0 as that number, A, we should not get 1 back, or this is saying that we don't get 1 back. Okay? If you type in, and it varies on calculator. So here's where the issue is. It varies on calculator. So if I use this calculator, or if you use, like my red handheld calculators that I have that are somewhere around here, if you type in 0, maybe we get there. If you type in 0 raised to the 0 power, hit enter, it gives this error, right? Okay. So that tells me that we've got a problem here. Okay. Can we really evaluate this? But if we go to Desmos, let's see what Desmos does. I'll take 0 raised to 0 here. Desmos actually tells me it's 1. I think I'm going to go through an exercise with you probably tomorrow that maybe argues against that it should be 1. Okay? If we look at, let's see what GeoGebra does. We go 0 raised to the 0. It is programmed to give me back 1 as well. These are things that we will talk about in the next couple of days. But our text, okay, and the problems that we do, when it says 0 raised to 0, that's undefined for us right now. Okay, we'll talk about maybe applications on why sometimes 0 to 0 is 1, and other times why 0 to 0 is undefined. We're going to say it's undefined for us. Does that make sense? Okay. So no matter what you plug in, so I think I can demonstrate that here real quick with you with Desmos is to look at this. I say A raised to the 0 power, and it says create a slider for A. So what's going to do, right now this is evaluating 4.3 to the 0 power. Does that give me 1 back? And as I push that play button, that 1 stays 1 all the time. Does that make sense? So it's showing you at least between -10 to +10, no matter what number you put in there, raised to the 0 power, you get 1. Okay? Understand then, well, what if this was raised to like the 2nd power? So I want you to see that this is actually calculating something. There we go. Keyboard wasn't working right. So as I go to the 2nd power, I would assume that A squared is changing, right? Okay. But again, if it is to the 0 power, it doesn't change. It's always constantly 1. Okay. So that's a fact that we need to kind of commit to memory right now. Okay. The next rule that we talk about is negative exponents and how we operate with negative exponents. And this should kind of be the bulk of what we talk about today. It says for every non-zero number, A, in integer n, okay, if you take A and raise it to the opposite of n, okay, so give me a number for A.
1.
Give me another number.
7.
1's kind of boring. 7? Okay. So if I say A is 7, okay, let's say n is 2. Does that make sense? Okay, so if I choose these specific values, what this A to the negative n is saying is that you're going to take 7 and raise it to the -2. Does that make sense, everybody? We cool with that idea? Okay. It is then equal to, okay, so the whole practice here is ultimately that we don't like negative exponents. So we need to manipulate this so that we don't have negative exponents. What this says we're able to do is rewrite the numerator here as 1 and take this A, so this was A to the negative n, okay? We can take it and change it to A to the positive n as long as we put it in the denominator. Does that kind of make sense? Okay, and I'll maybe better explain that process here in a moment. But what I want you guys to see is that if I take 7 to the -2, gets that decimal, is that the same thing as 1 over 7 squared? Are those decimals the same exact thing? Or if I change it to fractions, do they both give me 1 over 49? That kind of makes sense? Our practice, and the things that we're going to do later on, for the most part, we're going to like to do them with positive exponents. Okay? There may be situations where maybe they start me off with 1 over 7 squared, and I actually change it to 7 to the -2, because maybe it makes the next couple steps a little bit easier. Okay? So, that is what we do with negative exponents. Okay? So, if I give you, let's say, 3 to the -1. 3 to the -1. So 3 is your A value, right? That's your base. That's this number right there. So when I write the right-hand side, when I change this to a different format, that base goes to the bottom. So I'm going to put 3 on the bottom here. And now the exponent becomes positive down there. So instead of -1, it becomes +1, and then the numerator turns into 1. Okay? Now, that leaves you with 1 over 3, right? What's 1 over 3 as a decimal? Yeah, 0.3 repeating, right? Okay? Well, if I type into, when we work with this stuff, guys, I'm going to toggle back and forth between Desmos and the notes quite a bit, just because I want you to see these values. I want to make sure that you understand that what I'm giving you is not just a bunch of malarkey. It's not a bunch of just garbage that I'm saying is true. I want you to see the technology, use it, and show you that the technology understands it the same way that we do it by hand. Does that make sense? So if I write 3 to the -1, does that give you 0.3 repeating? Just like 1 over 3 does, right? So in the whole grand scheme of things, when we're doing our algebra processes later on, 1/3 is going to be a nicer number, even though it's a fraction. It's going to be a nicer number for us to work with than 3 to the -1 is. Okay? So that's kind of the game that we're going to be playing here with this stuff. Okay? What we like to do, so that's kind of actually a special case almost of what this next paragraph says. Paragraph says, common practice is to never use negative exponents. We hate negative exponents, okay? When you're working on Math Excel and they ask you to simplify something or to write the simplest answer or something like that, if you have a negative exponent in your answer, it's going to be wrong, okay? It's part of the simplification process that as a math community we've decided we don't write answers with negative exponents, okay? Like I said earlier, though, there might be situations where as we move on through other courses, maybe what they present me with in regards to a negative exponent might be easier to work with as a positive exponent, or what they give me as a positive exponent might actually eventually be easier to work with a negative exponent. So we just have to be able to kind of jockey back and forth between these two representations of the same number. So we're going to want to change things right now into positive exponents. So the rule of thumb is that if a negative exponent shows up in the numerator, okay, which is exactly the case that we were dealing with in those examples above, because 3 to the -1, that is in the numerator, right? Okay. If your negative exponent shows up in the numerator, then you're going to take that base in that exponent and you're going to transfer it to the denominator. And when you make that transfer, it becomes positive. Okay? The next part says if your negative exponent shows up in your denominator, you're going to transfer it to the numerator. And when you transfer it to the numerator, it makes your negative exponent positive. Okay? So in the whole grand scheme of things, wherever your negative exponent starts, to turn it into positive, you need to change it changes position. If it started in the numerator, it goes to the denominator. If it started in the denominator, it needs to go to the numerator. Does that kind of make sense? And that transition changes it to be positive. Now, what I want you to understand is, well, why does it change positive? Why? Okay, why does it do that? Okay, it's not just Mr. Fay says that moving it makes it positive. There's a logical reason for that. Okay, but what stinks is it won't be for a couple more sections that we really fully understand that logical reason. And it's basically because when I'm moving it across the division sign, I'm actually dividing it by itself. And when I do that, it will eventually turn that negative into a positive. Okay? So we'll talk about that a little bit in section 7.3 and 7.4. We'll come back to this and talk about, so why does this rule that we've learned already exist in the way that it does? Okay? And that's the algebra, guys. We can do all these examples down here at the bottom and understand them and do them and be able to monkey see, monkey do, repeat what Mr. Fay does, do it in the homework, be successful, that kind of stuff. But do you know why you can do that? The why of why you can do that is the algebra. Okay? So, what I like to do, I want to go through here a handful of examples, okay, and see if we can kind of master this concept. All right. The first one here, question A, is not a fraction. Okay. When you do all of these, you're going to want to think about there being a fraction. Okay. Because the rule says start to move things from numerators to denominators, right? Well, if I don't have a fraction to start with, it's kind of hard sometimes for people to realize, well, what is the denominator? Okay? So if there is no fraction, what I want you to do is I want you to make it a fraction. So I want you to put this over 1. Okay? You're then going to write a division bar. Okay? And all we're going to do is we're going to go through every single term here and say, or ask the question, what's the base? Is the exponent positive? Because if it is, it stays put. It does not move. And then I ask it, what's the base? Is the exponent negative? If it's negative, then it moves to the other side of the division bar. And that's all we got to do. Okay? So if I look at this, 5 is a base, correct? Okay? What is the exponent right now that is with that 5? What is the exponent that's with the 5? The 3 is with, because remember what PIMDAS says, the exponent goes to the thing that is directly behind, right? Okay, so the 3 is directly behind A, right? Okay, so 3 goes to the A. What goes with the 5? Not 0. It'd be 1. And the reason it's not 0 is because if I took 5 and I raised it to the 0 power, what did we say that was earlier? It was 1, right? So they would write 1 there instead of 5. Okay? So when there's not an exponent written down for something, it's an understood 1, right? If we go back through all the variables all the equations we've done with x's and y's, wasn't there an exponent of 1 with all those x's and y's? We just didn't write it, correct? Okay? Same thing for natural numbers, whole numbers, integers, all that kind of stuff. Okay. So is that exponent that is with 5, is it positive? Yes. So it stays put. 5 is going to stay in the numerator. So I put it in the numerator. Okay? What I like to do, and I think this is a good idea, as I go through, I'm going to cross off the objects that I've already dealt with. So 5 to the first, I've dealt with that, I cross it out. And it just allows me to progress kind of systematically throughout the expression, so I know that I've targeted every single object that's in the expression. So now I go to the next base of A, and A is being raised to the third power. Is that 3 positive or negative? Positive. So does it stay or does it move? Stays. So A to the third stays right there. I'm done with it. Okay? Now I go to the next base, of B to the negative 2. That's negative 2. Is that positive or negative? Negative. So where does it go? Goes to the bottom. Okay? Now there's already a 1 in the bottom, but does 1 times B squared still say B squared? So if you want to put that 1 in there, there's nothing wrong with it. I usually don't write it. And then I'm done with that, right? And if you wanted to target that 1 and say, okay, well, I've got that 1 down there. I know it's got an exponent of 1 as well. It's an understood 1. And that's positive, so that 1 should stay in the bottom, right? Does that make sense? So that right there, 5a to the third over b squared, is identical to that. It produces the exact same results, okay? And what I want you guys to do, and I want you to realize and use this, okay, is that when you're on your homework, instead of just haphazardly hoping that that is the right answer, you should be able to check every one of these. And I like using the scientific calculator for Desmos. It's the one that you're going to see on your end of course exam. I'm going to write 5a cubed b to the negative 2. And I'm going to hit enter. And then I'm going to type in what I thought my answer should be. 5a cubed divided by b squared. Okay? Now, when I put those in, it gives me this warning. It says, we don't know what a and b are. Okay? So what we're going to do is we're going to have to define a and b. What's the number one thing you're not allowed to divide by? 0. So when you choose what b is, just avoid 0. Does that make sense? My suggestion when you're going to use Desmos or any other technology to substitute here for you, always avoid 0. Okay? I also like to avoid numbers that are the same. So I don't want a and b to be the same number. It shouldn't matter, but I just don't like it. So now what I'm going to do, I'm going to say A, give me a number. 4. And B, give me another number. 17. Okay? So I get those two numbers. Plug those in. So now what Desmos does is it plucks those numbers off, 4 and 17, and puts them in those spots. Does that make sense? Does it give the same two results? If these two decimals are the same, what's that tell you about these two things? They're the same. Okay? Now, just to prove my point, doesn't matter what numbers I chose for A or B. Those two things become the same, so that means these two things are the same. So that guarantees me that I know that's the right answer. Does that make sense? Okay? If they were different, because I get people to do this, they just go through and they say, oh, well, he said I don't like negative exponents, so I just make them all positive. If I did something like that, do you see now that these two numbers are different? And they're drastically different. Okay, that's times 10 to the 33rd, so that's times 10 to the 38. Those are drastically different values right there. Okay, so I want you to take the time to check these and make sure that you're doing things correctly. Okay, now let's look at the next one. Okay, what's the exponent that goes with this this 1 here? It's 1, right? Is that positive? So it stays put. 1's going to stay there. Okay? Now we go to the bottom. X to the negative 5th. Is that positive or negative? Negative. So where does it go? Goes to the top. Okay? I've exhausted everything. So what happens when you maybe move everything out of the numerator or you move everything out of the denominator? What is left in that spot then, the numerator and denominator, is a 1. And I'll explain why in a couple sections, but it's because of division. We're dividing essentially by itself, okay? So I'm left with a 1 on the bottom there, but anything written over 1, I could just rewrite this thing as x to the 5th, can't I? 1x to the 5th divided by 1 is just x to the 5th divided by 1, which is x to the 5th. Is that cool? Okay. So, come down to C. I put that over 1. Remember, if it's not a fraction, we make it a fraction. And then I just go term by term. Okay, so x to the negative 9th. Where should that go? Bottom, and it should become x to the positive 9th. Good. Okay, so that's done. And everything moved away from the numerator, right? So what should be left in the numerator? 1. Okay. Well, I want to kind of draw a comparison together. I think we've got a little time here. Science class, metric system. We talked about the metric system a little bit in this class when we did conversions. We talked about King Henry. died by, and I'm going to write base here, drinking chocolate milk, right? And you guys talked about the base being like your unit. So base is like 1 meter, 1 gram, or 1 liter, right? And this stands for deca, hecta, kilo. This is deci, centi, and milli, right? And basically what we did is we said, okay, well, if our base, if this is 1 meter, it's really, maybe makes more sense to write it as 1.0 meters, 1.0 grams, 1.0 liters. I was going to do one. I was going to deal with the base of meters. If I go deci, okay, does that mean that you had to move your decimal to the left 1 spot and it becomes 0.1 meters? And then centi was moving this base decimal 2 spots to the left, so it became 0.01 meter. So 1 centimeter is 0.01 meters, right? Does that kind of make sense? And then milli is moving it 3. So 0.001 meters is equal to 1 millimeter. Okay, that's kind of how we dealt with this stuff. Okay, but 0.1 as a fraction. You may know what 0.1 as a fraction is. 0 over anything is going to be 0. But this is, so this 0.1, I read that as 1/10, right? 0.1 is 1/10. That's how you read it as a decimal, correct? So 1/10 as a fraction is 1 over 10. This is 1/100th, right? So that's 1 over 100. This is 1/1000th, so it's 1 over 1,000. And that should make sense. It takes 10 decimeters to make a meter. It takes 100 centimeters to make a meter, right? It takes 1,000 millimeters to make a meter. We all in agreement with that? Yeah. Okay. If you were to Wikipedia this or something like that, and we will see if the logic shows up here. They're going to talk about the metric system being powers of 10. If I take 10 as my base, what do I need to raise it to so that I get 1? What can I raise a number to get a base of 1, to get a result of 1? Any base raised to what will give me 1? 1. If I raise that to the first, so remember what this means. I'm going to take 10 and multiply it by itself 1 time, and that should give me 10, right? What was the first thing we wrote in our notes? 10 to the what will give me 0, or give me 1? 10 to the 0. Okay? 10 to the 0 equals 1, right? Now, 1/10, what is that denominator right there? What is the power of that 10 right there in that denominator? 1. If I move it to the top, I could rewrite it that way. Does that make sense? So when we talk about like a to the negative n is equal to 1 over a to the n, we usually go from this to that. But we can start on this side and rewrite it that way. Does that make sense? It's an equation, so it's a two-way street. So if I have 1 over 10, I can write that as 10 to the negative 1. So what would 1 over 100 be? 10 to the... You guys agree that 1 over 100 is 1 over 10 squared? Can I put that up in the numerator as negative 2? Okay, so 0, negative 1, negative 2. What do you think the next one's going to be? Negative 3. If I go this direction, 10 to the... Careful, we already got 0. You went 0, negative 1, negative 2, negative 3. 10 to the first. A hecta is 10 squared. 10 cubed. If we were to look at, let's just see, Wikipedia metric system. See if they got a graphic here showing anything we're doing here. Right here. Well. See there where it says, so None would be my base. You see where it says 10 to the 0? Deca, 10 to the first. Hecto, 10 squared. Kilo, 10 cubed. And now deci, 10 to the -1. Centi, 10 to the -2. Does that kind of make sense, everybody? So what I'm hoping to draw a link between there is you've been using this logic in the past, or things that use this logic. All right, and the hope is that once we start understanding this a little bit deeper, we can kind of open the door to a whole lot of other things that use negative exponents and how we address that and deal with it. Okay, so let's take D here. Let's put that over 1. What's the exponent with the 4? 1. Okay, so positive or negative? Positive. So where's it going to go? It's going to go on top. So 4 the first. So now what's the exponent that goes with C? -3. So where's that going to go? Bottom. Okay, so I've used the 4. I've used the C. B, where's B going to go? Top. Just okay? All right. Do that last one on your own real quick. Good. Good. I'll merge those together. And what's the exponent with the 4? 1. What's the exponent with the 2 on the bottom here? 1. So I always go through the things that don't have exponents written on them, especially early on, the first time we're doing this, guys, is I go through and I make sure I put that in. Because the fear is that somebody's going to put that 4a cubed in the bottom. Does that make sense? Where only a cubed goes in the bottom, the 4 stays up top. So I want you to make sure that you're doing that and paying attention to that closely as we first start these on this first couple days. So the 4, positive, so it stays up there, right? Done with the 4. A to the -3. Where's that going to go? Bottom. B stays on top because it's positive 1, right, as my exponent? Okay. So I'm completely done with the numerator, right? But there's things in the bottom that I have to address with as well. So I got to go through the bottom and say, okay, do they stay or do they move? So the 2, does it stay or does it move? Stays. And it's 2 to the first, right? So I'm done with that. Now C to the -2, does that stay or does it move? Moves. So it becomes C squared. A lot of times, guys, will rewrite this. They just like to write your constants out in front. Okay? Because eventually, when we start simplifying, what are you going to notice that you can do with a 4 and a 2? You can divide those. Okay? I'm not going to really worry too much right now about that, but that will be the practice eventually. Put all your coefficients out front and see if there's a GCF between them that you can factor out. Does this negative exponent stuff make sense? Okay, so the next couple of sections, guys, is going to bring in more ideas, more concepts. But each section, it will incorporate at times negative exponents. And when we see them, we got to know what to do. When we see 0 as an exponent, we got to know what to do with that. Okay? And basically what we're trying to do here is just simplify algebraic expressions that they give us. Okay? A lot of this chapter is going through what we call laws of exponents. Okay? Things that we have to go and abide by. Okay? But now, I want you to understand, what we're going to spend time on a little bit, when I say laws of exponents, every law should have a reason, right? A logical reason, correct? Okay, if I've got, there's a law that I have to drive 55 miles per hour, or I got to go 20 miles per hour in a school zone. Why do I have to drive 20 miles per hour in a school zone? So I don't hit the kids. I mean, there's a logical reason for that, right? So when I say why is 0, anything raised to 0 power equal to 1, that's a law. There's got to be a logical reason. So hopefully tomorrow, if you look through the next page, there's some charts there. Tomorrow, we'll go through those charts and talk about why something raised to 0 is going to turn into 1. Okay? And that kind of stuff.